Hi, welcome. In this video, we are going to describe how to build an Atlas search service in Java. This video is a companion to the article that I wrote and published recently that details, again, how to build a search service in Java. So let's jump right in. So what we need to do is we need to code our way from the search box to our Atlas cluster. So we've got Atlas over here, we've got a database, documents, and we've enabled Atlas search on our documents here, and we need to be able to make search requests from the search box to our Atlas search index. We're going to do that by building a middle tier. So a typical three-tier system has a presentation layer. Users are entering and controlling the search UI here. And we have a data tier, and typically you have a third tier. You have a middle tier that is the interface between the user input and the database. So what we're going to do is we're going to build a search service here. This search service here is going to take requests from the UI and proxy those to the Atlas search service through an aggregation pipeline. And the reason that we need this middle tier gives us some isolation. We can have the connection string here so that all credentials that make requests to Atlas are in this tier. There's nothing in the presentation tier that needs to know exactly what's happening back here. Also, we have scalability concerns. We might need to scale out the ability here so we can make a stateless search service here and proxy through a router here and scale out number of search services. These search services are able to be flexibly deployed too. We can version these, we can keep one running while we bring up a different one and make code changes in place basically and control versioning. We can isolate the code generation that's going to generate our aggregation pipeline so that the UI development team doesn't need to know how to do the aggregation pipelines, but our data services folks can code the aggregation pipeline here in isolation of the request from the UI tier. Also, this gives us the ability to have clean parameters from the search box into the Atlas search index. So again, the developers here don't need to know all of the gory details or embed those gory details of aggregation pipelines into this tier. It can all be right here. And again, this tier can change as needed to make adjustments on how that aggregation pipeline is formed without affecting the deployment of the presentation tier. Let's talk about the design of this. There's a few things to talk about design-wise here. What we're going to do is make this an HTTP GET service. It could be GET or POST. Right now it's a GET service. And this service here is going to take several parameters, just the basics that are needed from the presentation tier. So there's the query itself. We'll call that Q. And then also, because the users are searching, they're not going to get all of the search results back in one view. So we want to have a limit. So we're going to have the number of results as a parameter. And we're also going to have the page number, right? So they could be page 1, 2, up to n pages. Which page are they viewing and how many per page are they viewing? Other features that you'd want in this search service are control over what fields are being brought back. There could be large textual fields that you don't need to display, but you're going to search across. So maybe you only want to show the title and a category and the price of things in the UI, but you might want to search the full description and so on, and maybe not display those. So you have control over the fields that will be returned. We're also going to take care of some error handling too. So if some of these parameters aren't provided by this search UI, then this service can respond back with an appropriate error message that says this parameter is missing, for example. Another parameter that might be in here that's very necessary and often used is filtering. So you might display the categories or genres on the UI and allow users to search within a particular category. And we're going to allow a parameter to come in that says what filters need to be in play to limit the results that are being returned and searched here. So the parameters, let's be concrete about the parameter names that we're going to have here. We're going to have Q. We're going to have search. This is going to be a parameter that tells us what fields we're going to search. We're also going to have a limit. We're going to have a skip. So this is going to give us pagination controls. We're going to allow the projection. So we have a project, and then of course the filter parameter here. So these are the basic parameters that we need for our search service. We can expand it later. Again, we could even expand it without affecting the UI here and add new parameters here that new UI could take advantage of. Another handy feature in an interface like this is a debug parameter. So let's add a debug parameter so that we can get some insight into what's actually happening end to end here from the outside. Next thing we need to have here. So we've talked about the request. Now, the response that comes back from our search service is going to provide the documents. So we've searched for documents here. We're going to return those documents over here that match our search query. And we also need some additional information here. We need to know the total number of results because we may only be showing 10 results here, but thousands could have matched. So we want to show the pagination controls. We want to tell the user how many results are actually matching their query, even though we're only showing them 10. So we need to return back a count over here. We also want to give some insight because there's a stateless environment here. We might want to also provide back the request details for the calling application, even though they sent the parameters in. We also want to give those parameters back and also fill in the blanks because they may not have provided some of these parameters, but we'll give back the default values that were used in our request details here. And again, we're going to have a debug option so that some debug information is available optionally from their requests. Let's drill in and talk about the implementation here. So we've gone through the design and the interface and the response format here. Now let's talk about this thing in action. So first things first, we're going to look at how this is configured in Atlas. So in Atlas, we have an Atlas search index. There's an example on the sample mflix data that comes with Atlas. There's a movies collection, and we built a movies index on that movies collection. That movies index configuration looks like this. Now it's a little bit tuned here specifically for the movies data. All of the movies data in that sample data is in English. So we're going to use the English analyzer. And then there's several fields that we're going to specifically map in different ways here so that we can do matching on and filtering by genre or by year or by cast member, that sort of thing. So we have some configuration here that maps cast members to both string and to token. The token type allows us to do equals. The string type allows us to search within for words, again, using an English analyzer here for that one. And we can also facet by cast. And likewise, we can do the same with genre. So we can do equals or in comparisons there. We can also do textual matches, and we can facet by genre. And similarly with the year. So this is what it looks like through the visual builder. We can also take a look at what this looks like in JSON. So you can just get a quick view of that configuration here. Bump the size up a little bit here. So you can take a look at this. All of these details are in the companion article to this video. So now let's start making some requests to our search service. Our search service, again, is implemented in Java here. It is a standard servlet. We've mapped our connection string into the configuration. While the search service is running here, and we try to go to our search endpoint, the search endpoint gives us an error message saying that there are some parameters missing. So in this particular case, we need to provide a Q. We did not tell it what our query was. Now let's give it a query. So we gave it Q equals matrix right here. Again, not sufficient to know what we're searching. We know we're searching the movies index, And we know we're searching for the word matrix, but what fields are we actually searching there? So we can provide that by saying we're going to give Q equals matrix and search equals title. So we're searching the title field. In this particular case, we're searching the title field. We get 3 total documents back. This is the response format that I mentioned here. So we see the request details, and we see some meta information giving us the count, and we see the documents. We're seeing the documents in all of their glory straight from Atlas. So all fields for all the matching documents is being returned. That could be overwhelming. So let's control that a little bit further. So we can say search title and plot fields in this particular case. And you can see that parameters are also returned here in the request side of things. So we are searching the title and plot fields. We are projecting only the title, genres, and year fields. So our results are much more compact. And you can see here our request is also data that's being returned tells us what the defaults are. We didn't provide a skip or a limit, and we didn't provide a filter or even sort, but it tells us this in here, what these defaults are. All right, so there's 5 results that are being returned right here. This is because we are now searching the plot field as well, and there just happens to be some movies, not just the 3 matrix movies that match in title, but there's some that match in the plot as well. So we can provide a filter to give us just the information that we want for a particular genre. So we can filter by genre. Right here, we're filtering by the animation genre, and we can see the 2 movies that match the word matrix in their plot, but not in their title here, because animatrix doesn't match the word matrix in this particular type of query. And our next example here is showing that we can do an inverse filter. Now, this inverse filter, or negative filter, is not something that was built at the time the article was published. This is something that I added after the article was published as a feature request here. So we can say we want to exclude all documents that match animation. So now we're getting action and adventure type movies here, but not ones that are animation, which those other 2 were. And finally, let's look at what happens if we turn on debug here. So we've added the debug parameter. This debug parameter gives us the entire explain output from Atlas. When we make our request with our aggregation pipeline, we can call an additional method to tell it to explain what happened. There's a lot of detailed information that is returned there. But one of the things that we also get is the pipeline that was generated. So the pipeline that was generated from those simple parameters that we provided, where we said, we're searching for matrix across title and plot, give me back title, genres, and years, filter out animation movies, only search within movies that are not animations. And this is the pipeline that got created. Let me just go over to this other screen here, and we'll zoom in on that particular one. So this is the pipeline that was created for that particular request, where we can see that our parameters said search matrix in the title and plot. It must not be an animation genre. We turned debug on, so we're getting the scoring details back. We are returning the count, and we're skipping no documents, returning back just the first 10, and we're projecting out title, genres, and year, not the ID field, and we're also getting back the scoring details when the debug mode is enabled. And then all of that gets wrapped inside of a response stage called $facet. This stage allows us to build a structure called docs, meta, and we'll also put the request information in there in our search service. Let's just wrap this up. So future possibilities. The article mentions adding negative and exclude filters. Implemented. Done. We also had a feature request after the article was published for highlighting. I implemented that. That's done. There's several other things that would be nice to add to this. Things like faceting. That's not in there in the current version. Again, let's just reiterate, with this service being a middle tier here, we can independently deploy that without necessarily having to change our front end or even the data tier. If there's some changes that we want to make here, to enhance the requests on either end. And in conclusion, implementing a middle-tier search service provides numerous benefits, from security to scalability to being able to isolate changes and deployments independent of the presentation tier and other search clients. Additionally, a search service allows clients to easily leverage sophisticated search capabilities using standard HTTP and JSON techniques. Happy searching!